So we just figured out the formula for the partial sums of the geometric series. And I claim that this formula will allow us to calculate the value of the actual infinite sum. Pretty cool stuff. So we got to figure out what happens depending on whether R is big or small. And as usual, I mean in absolute value. So notice the only time that n shows up in the formula for the partial sum is on that exponent of R. So when I take a limit as n goes to infinity, my a is going to stay the same, my 1 is going to stay the same, my r is going to stay the same, but this r to the power n will do different things depending on whether r is large or small. So if r is between -1 and 1, or you might say if the absolute value of r is strictly less than 1, then this limit, the limit of the partial sums, will tend towards the value of a divided by 1 minus r. So this r to the n, maybe this is a half, and then it's a quarter, and then it's an eighth, and then it's a 16th, and so on. So that will tend to 0. I'll have a times 1 minus 0 divided by 1 minus r. So this would be the limit of the partial sums, which means that the limit of the partial sums converges. We even have a formula for what it would converge to. But if the partial sums converge to some limit, that means that the infinite sum converges to this limit. So the geometric series will equal a divided by 1 minus r, so long as this condition is true, so long as r is between -1 and 1. Now, what could happen if r is not between these two numbers? Either our common ratio r is less than or equal to -1, or the constant ratio r is strictly greater than 1. We already covered r equals 1 in the previous video clip. Well, in both of those cases, the sequence consisting of just r to the power n diverges. So the r to the power n in this formula diverges. That means that the limit of the partial sums does not exist. So just depending on r, we can figure out whether or not the geometric series converges. So here it is written up as a very nice formula, and this is an incredibly useful tool. So here already is a nice family of series of infinite summations that we can already calculate and actually get a number for the answer. So as long as your common ratio r has absolute value strictly less than 1, the series converges and we will get a, which is the first number in this sum, divided by 1 minus r. And then if the absolute value of the ratio is greater than or equal to 1, the series diverges. So, let's actually put this into practice. Let's calculate some stuff.